Today, let's go over another medium grind 75 question. This one is called search in rotated sorted array. So I've solved this one I solved it last month just as review. So let's do it again. There's an integer array called nums sorted in ascending order. So integer list from smallest to greatest with distinct values. So that's important. There are no duplicates. Prior to being passed your function, nums is rotated at an unknown pivot index, such as the resulting array is something. But the important part here is that is target inside of this array, and if it is, return the index that it appears in. And if it's not, then return -1. And the kicker here is you have to write an O of log n time complexity because it'd just be easy to go over the array and ask if it's equal to target. If it is, return I. If you get through the entire array and it's not, return -1. That works, but it's not what they're looking for. So as you can see, there's a better way to do this, and that's to use binary search. So let's sort the array first. So now we have 0, 1, 2, 4, 5, 6, 7. And let's start a left and a right pointer, right? So left starts here, right starts here, and we're going to close the search space by asking if the current target value, because this is a value, right, not an index, is less than or equal to the midpoint, just like before. So again, midpoint is going to be here. And since target is less than the midpoint, we're going to close the left pointer, and the next iteration is going to look like this, and vice versa. And by the end, the two pointers are going to touch or cross, or if they touch and you never return anything, then we're returning -1. So this is just a standard binary search. Let me show you how to code it up now. So defining the two pointers at the left and the right of the array, the first and the last element. And while the two pointers don't cross with equals because we don't want to miss results, now we have a midpoint. Left and right are indices here. So if nums of mid is equal to target, then we can just return mid, right? Because mid is the index, like I said. We want to return that if it happens to be at index 4, 0, 1, 2, 3, 4, right? If that's not the case, then we're going to throw away half of the array because we already sorted it. So if mid is too big, then we close the right pointer. If mid is too small, the only other condition left, then we close the left pointer. And then at the end, if the two pointers touch and we don't find anything, then we can just return -1. Okay, so looks like we have some issues here. Let's print mid. 310 0 1 2 3. Right, if nums of mid is too big. Oh, the problem is that we changed the ordering of the array. So how about let's map the original first. So let's say that equals to dict for I and in enumerate nums. We're going to map the index to the value. So d of I is equal to n, or d of n is equal to I, because you can't use the values to get the key, only the key to get the value. And if we're equal to target, then just return our current value is nums of mid, right? That should be something in the array. So return d of nums of mid. Cool, there you go. So as you can see, it passes all test cases, and this is a better way to do it because this is not another O of n. So hope this helped, and stay tuned for more in the future. Thank you for watching.